Right, in this video we're going to talk about bearing, right? What a bearing is something that's used in navigation, whether you're using an airplane or a boat or something like that. It's a way to tell which direction you should travel, right? So what the bearing is, it's an acute angle. Remember, acute means less than 90 degrees. So it's an acute angle measured from due north or due south, right? So for an example of a bearing would be north 30 degrees east. Right, so if I'm told to go towards the bearing north 30 degrees east, it means face north. So let's say this direction is north, and then turn 30 degrees towards the east, and then go in that direction. Right, that's your bearing north 30 degrees east. Right, so it's 30 degrees to the east of north. Right, so to kind of show you on a diagram here, here's due north. If I turn then 30 degrees toward the east, I go in that direction. That's my bearing north 30 degrees east. Right, so bearings are always measured from due north or due south. So it's north some degree east or north some degree west if I'm turning this way, or it's south some degree east or south some degree west to take me in those directions. Right, so it's always based off of due north or due south, and then acute angle. Remember, it's always less than 90 degrees. So it's never like north 150 degrees east. Right, if it was that, I would just say south 30 degrees east, and it would take me there. Right, so those are bearings. That's an example of a bearing. I'm going to pause this now, erase this definition, and we'll do an example of, I think, flying in an airplane using bearings and trying to figure out where we're going. So here's the problem we're going to do. A pilot takes off from an airport. His bearing is north 20 degrees east, and he's flying at 200 miles per hour. Right, after 1 hour, he changes direction to north 40 degrees east. Half an hour after that, he has to make an emergency landing for some undisclosed reason. All right, so the first thing, we want to find the distance between his airport and his landing point. So how far is he from where he took off? All right, so first thing we should probably do is try to draw a diagram of what's going on here. Now, these types of problems with bearings can get kind of complicated, but I'll walk you through it as best I can to explain how we do this. Right, so start off with his airport, where he takes off from. So there's A for airport, or A for the first letter of the alphabet, however you want to see that. And he's traveling, when he takes off, north 20 degrees east. So let me draw a little, like compass rose here, or at least the north, south, east, and west. And he's going north 20 degrees east. So north, and then he's turning 20 degrees towards the east. He's going that way, right? And that's making an angle here of 20 degrees. All right, so that's the first part. He's going 200 miles per hour for 1 hour. Right, so if he goes 200 miles per hour for 1 hour, how far does he actually go? Well, he's going to go 200 miles, right? 200 miles per hour. 1 hour, that's 200 miles, right, per that 1 hour. Right, so he goes a total distance in that direction of 200 miles. All right, so we know that length right there is going to be 200 miles. And then he changes direction to north 40 degrees east. So from that point where he changes direction, if I draw another little compass thing, right, and now it's going to be north 40 degrees east. So now from north, he's going 40 degrees towards the east. So that's going to be going off in this direction now with an angle of 40 degrees there. And he does that for half an hour before he makes his emergency landing. Right, so if he's going 200 miles per hour for half of an hour, how far does he go in that case? Well, that's going to be 100 miles. Right, if he goes 200 miles in 1 hour, and he's going the same speed for half an hour, he's going half as far, he's going 100 miles. All right, so that's our thing, that's the information that we know here. And now what we want to figure out is the distance between the airport and the landing point. So let me erase some of these little dotted lines here. So we want to know the distance from where he was to where he ended up. Right, so that's my x, is that straight line distance between the airport and his emergency landing point. All right, so what do I know? What can I figure out? I know two sides of my triangle, right, the 200 miles and the 100 miles. If I could figure out that angle in between those two, I could use the law of cosines then, because then I would have two sides and their enclosed angle. I could use the law of cosines then to solve for that other side, x. So that, I think, is going to be the strategy we want to use here. And the way we can do that is to figure out this angle. Since I know the bearings here, that this is a 20 degrees off of north and this one is 40 degrees off of north, well, if I extend this line here that he was flying on, right, he was 20 degrees from north, so he turned another 20 degrees from his original direction, right? Does that make sense? So he's going 20 degrees this way, he's flying for a while, And then to get to north 40 degrees east, he had to turn another 20 degrees. Right? So what angle is inside here? If he was going straight and then he turned 20 degrees, well, if he went in a straight line, it would have been a 180 degree angle. He's taking 20 degrees off of that, so this angle in here is going to be 160 degrees. Right? So let me kind of go through that again to make sure it made sense. Right? He started off north, turned 20 degrees to the east. He goes in a straight line for 200 miles. He gets to this point. To get to north 40 degrees east, well, he's already going 20 degrees to the east, so he has to turn 20 more degrees towards the east, which takes him off of that straight line that he was going on by 20 degrees, which means that angle that he turned is 160 degrees, right? Because 160 plus the other 20 makes that straight line that he was going on, which would have been 180 degrees, right? So if I can kind of draw this triangle without all this other stuff on it, hopefully it'll be a little bit easier to see. So we have 160 degrees here. This distance is 100 miles. This distance on this side is 200 miles. And I'm looking for x, the distance that he is from his original, takeoff spot to his landing spot. All right, so once again, I did another video a while back where I talked about, sometimes in the problems you have to draw extra lines in there in order to figure stuff out. This is another case of that. Right? Just looking at what they gave us is it's kind of hard to tell what that angle in there is going to be. But if you think about it as turning 20 degrees, going in a straight line, turning 20 degrees off of that straight line, well, that's making an angle of 160 because the straight line had to be 180. All right, so now we have all the information we need to solve for this side x using the law of cosines. Right? Remember, law of cosines we can use when we have two sides and their enclosed angle, their included angle. All right, so let's set up our law of cosines here and solve it. So unfortunately, I'm going to have to erase the story up there. And I'm going to erase this other drawing too. If you want to see it again, just rewind the video and go back and look at it. All right, so there's our triangle. I want to find side x, right? So x squared is going to equal the other two sides squared. All right, so 100 squared plus 200 squared minus 2 times those other two sides multiplied together. So 2 times 100 times 200 times the cosine of the angle opposite x, which is 160 degrees. All right, and if you haven't seen the videos that I did on the law of cosines, definitely check those out. Otherwise, what I wrote up there makes no sense whatsoever. It's just a bunch of numbers and stuff. But that's following the law of cosines formula, right? One side squared equals the sum of the other two sides squared, right? Minus 2 times those two sides times the cosine of their included angle. All right, so now I can just type all that stuff in the calculator just as it is. So it's 100 squared plus 200 squared. I hit the wrong button there. 100 squared plus 200 squared minus 2 times 100 times 200 times cosine of 160 degrees. Double check that my calculator is in degree mode. Always an important thing with these problems. When you're doing trigonometry, sometimes you're in radians, sometimes you're in degrees. So it's a really good idea to check each time to make sure you're in the proper mode. Simplest mistake to make is just have your calculator in the wrong mode. It just screws everything up. All right, so there's what I type in. I hit enter, and I get my value, which I cannot see that backwards in the camera here, 87,587, right? But remember, that's not our answer. Right? That's not the distance here. That wouldn't make any sense if he went 200 miles this way and 100 miles that way, and he ends up 87,000 miles from where he started. That makes no sense at all, right? That's not what x is equal to. That's what x squared is equal to, right? So x squared is equal to 87,587.7 ... and so on. All right, that's a decimal point there. All right, to solve for x, to figure out the actual distance, I need to do the square root of this answer that I got. All right, so I do the square root of my answer, and I get 295.95. So let's call that 296 miles. All right, so he is 296 miles away from where he took off. Right, so how far did he actually fly? Well, he flew 200 miles and then another 100 miles. So he flew 300 miles, but he actually ended up 296 miles in a straight line distance from where he took off, right? Because he made that turn there, it kind of shortened the distance from where he is to where he ended up. All right, so that's our distance, using the law of cosines here with the bearing to figure out where we are. And then the part B of this problem asks us to find the bearing from the airport to his final landing point. Right? So let me pause the video here, pause the recording, I'll erase some of this stuff, and then I'll kind of set up that next part of the problem. Part B of this problem asks us, what is his bearing from the airport to his final landing point? Well, we know that he's north and then turning towards the east to get there. And remember, his original bearing for his when he took off was north 20 degrees to the east. Right, so that's this little angle that's in here in between the north direction and then the actual flight path that he took. That little angle in there is 20 degrees. So if I can find this angle of the triangle down here and then just add that to the 20 degrees that he already turned, that would give me his bearing from his airport to his final destination. Right, so to find this angle of the triangle down here, I could use the law of sines, right? Since I know one side, the 296 that I just solved for, and its opposite angle, the 160 degrees, so I can set it up as the sine of 160 degrees over the distance, the length of the side, 296, and then that's going to equal, and then I want this angle down here, and once again, let's call that A for the airport that I took off from. So I want the sine of angle A over its opposite side, which is that 100 that's over there. Right? So remember, the law of sines relates angles with their opposite, or the sines of angles with their opposite sides. Right, so the sine of this angle, 160, over the opposite side, 296, equals the sine of the angle down here, A, over the opposite side of 100. Right, and then I can solve this equation for angle A, and then add that to the 20 degrees to figure out his actual bearing from where he took off. Right, so if I multiply that 100 to the other side, right, I would get that sine of A is going to equal 100 times the sine of 160 degrees, all of that over 296. And then once again, just like with a lot of other problems I've done in some of these recent videos that I did, if I want to solve for an angle, I need to use the inverse trig function. Right? So I need to do sine inverse on both sides to cancel out the sine function on the left side. Right? So I get angle A is going to be sine inverse of 100 sine 160 degrees all over 296. Right, so if I type all that in my calculator, that will give me angle A. Right, and if you don't understand what I was doing there, go back and watch some of the videos that I did on the law of sines, where I explain what the law of sines is, and I do some examples that are just like this, where we're trying to solve for an angle using the law of sines. At this point, I'm assuming that you've either seen those videos or you already know how to use the law of sines in order to solve problems, and then we're just kind of using that to solve this problem here. Same thing for the law of cosines that I did before to solve for this x. If you don't understand what I did with the law of cosines, I did some videos explicitly on the law of cosines and doing some examples of solving for sides. So go back and check out those videos as well. All the techniques that I'm using here, I have talked about in other videos. So you can use those if you want to kind of catch up if you haven't seen this stuff before. All right, so I do like sine inverse of all that stuff. I get angle A equals 6.6 approximately degrees. Right, so angle A, the bottom of this one down here, is 6.6 degrees. Right, that's the angle at the bottom of that triangle. Right, so the bearing that this pilot took, well, he took off, he went 20 degrees, and then he ended up another 6.6 degrees. So if I add those two together, 20 plus 6.6, his overall bearing then was north 26.6 degrees east. Right, that's the bearing from the airport where he took off to his final landing point. Right, so if he has to call back to the airport for help, because remember he had to make an emergency landing somewhere, and they're like, all right, we're going to come find you, but where are you? He can tell them, well, take the bearing north 26.6 degrees east, go for 296 miles, and that's where you're going to find me. Right, rather than following the path he took, this bearing and then turning and going that way, they can just go directly to him and find out where he is. All right, so that's a problem involving bearings. Remember, bearings are always off of either due north or due south, and just you're turning either to the east or the west, or if you're south, turning to the east or the west. And then, once you have that, you use the law of cosines or the law of sines in order to solve for the sides and the angles of the triangles that are created there. And it depends on the information that you have. Right? For some information, like when we have a side and its opposite angle, we can use the law of sines. If we have two sides and the included angle between those sides, then we use the law of cosines, right? So deciding which one to use is an important thing to be able to do based on the information that you have about your triangle. And like I said, go back and watch the videos that I did on the law of sines and the law of cosines, where I explain like when to use each one in a lot more detail.